Hi, so I've just received another shape problem on my Facebook feed, and actually this is actually quite nice. It's something that requires quite a lot of thought. I looked at it initially, I thought, how am I going to do this? So what we're presented with is a cone, which is laying on its flat base and filled with liquid, well, it's partly filled with liquid. There's an 8 centimeter height difference between the top of the liquid and the apex of the cone. But when the cone is inverted, the liquid obviously falls down to the apex, and therefore the water level changes or the liquid level changes. So the difference between the surface of the liquid and the base of the cone then reduces to 2 centimeters. We're asked to figure out what the height of the cone is. So the key to this problem is to figure out an expression for the two volumes, which are going to be equal. The volume of the blue frustum on the left, and on the right we have the volume of the small blue cone within a cone. Okay, so I need to work out the volume of the entire cone, which is going to be a third pi r squared h, where r is the base radius of the whole cone and h is its height, which is what we're after. And then from that I'm going to subtract the small cone, the 8 centimeter high cone, to get the volume of the frustum. So that's going to be a third pi, I'm going to call that r1 and square that times 8. So if I just put the 8 on top of the third here, I get 8 thirds pi r1 squared, where r1 is the base radius of the small 8 centimeter cone at the top. And on the right hand side I've got another volume, which is going to be the blue cone, which is inverted. So I know that the height of that is h, which is the height of the whole thing, subtract 2. So the volume of the blue liquid on the right hand side is a third pi, and that's going to be r2 squared, because again we don't know what that is, because that's the base radius of the blue cone, times h subtract 2. So what we have now is two expressions which are numerically equal, so I'm going to equate them. A third pi r squared h minus 8 thirds pi r1 squared, and that's going to be equal to a third pi r2 squared h minus 2. Okay, so we can divide through by the one common factor, which is a third pi, so it simplifies out to be r squared h minus 8 r1 squared equals r2 squared h minus 2. Okay, we've got three unknowns. We've got the radius of the base radius of the whole cone, and the two smaller base radii r1 and r2. So there's lots of stuff we don't know here. What I'm going to do, just to simplify things up a little bit, is divide through by r2 squared. Okay, so we end up with r squared over r2 squared h minus 8 r1 squared over r2 squared equals h minus 2. Okay, so what we now have is some ratios of the radii. So what we can do with that is we can use a cross section of the entire cylinder, sorry, the entire cone, and use similar triangles. So we've effectively got a triangle here, right angled, which is h and r. We've got another triangle which is going to be h minus 2, and that's going to be r2 under here. And we have a third triangle, which is going to be 8, little right angles of course, and that's going to be r1. Okay, and we know that those three ratios are all equal. So that's going to allow us to form a relationship between the ratio of the radii r, r1 and r2. So as you can see, we've got our three triangles for each of the three different cones that we need to calculate. So we've got the whole cone at the top, which has got height h. Then we've got the small cone, which has got a height 8 and radius r1. And then we've got a further final cone, which is h minus 2 high, and the radius r2 as we've defined it earlier. So what we can do is we can use the fact that they're similar triangles, and I know that h over r is equal to 8 over r1, which is equal to h minus 2 over r2. So those three ratios are the same. We're effectively finding the tan of that angle theta in each case. So tan theta is equal to all of those. So we can use that relationship to eliminate our awkward ratios we've got in our first equation. I'm going to call that one 1. So what we can do is we can say that h over r is equal to h minus 2 over r2, and from that we can get r over r2, I'm just multiplying through by r, and then divide by h minus 2, I get h over h minus 2, and I can square both sides, okay, and we get the ratio r squared over r2 squared, which is what we want to eliminate. And then we can go further with the second relationship. 8 over r1 from here is equal to h minus 2 over r2, and from that we can get the ratio r1 over r2 by simply multiplying by r1 divided by h minus 2, and we get 8 over h minus 2, and once again we can square all of that. So we've basically got two relationships which I'm going to call 2, and we can sub them into equation 1. So if we do that, so initially we're going to start off with r squared over r2 squared, so we end up with h squared over h minus 2 squared. This bit I'm going to multiply by h, so that becomes h cubed, and then I'm going to subtract 8 times, and now we're going to substitute r1 squared over r2 squared, which is going to become equal to 8 squared over h minus 2 squared. So once again we can rub that out and turn that to 8 cubed, and we know that that is equal to h minus 2. So if we multiply everything through by h minus 2 squared, we end up with h cubed minus 8 cubed equals h minus 2 cubed. So what we now have is a cubic with just one unknown, which is exactly what we're after. We're after the value of h. So I'm going to expand h minus 2 cubed and see where we go from there. So here's our cubic equation in h, the height of the large cone, which is what we're after. So first thing I'm going to do is expand out my h minus 2 cubed. For that I'm going to use Pascal's triangle. Because it's to the power of 3, I'm going to need 4 terms, so we're after the fourth row of Pascal's triangle. So it becomes 1 h cubed plus 3 times h squared times negative 2 to the power of 1 plus 3 times h times negative 2 squared, and then finally plus 1 times negative 2 cubed becomes h cubed minus 6h squared plus 12h minus 8. So we're going to sub that in place of h minus 2 cubed on the equation we have up here, equation 1, and we're going to get h cubed minus 8 cubed equals h cubed minus 6h squared plus 12h minus 8. So quite conveniently our cubic simplifies to a quadratic because our h cubed terms on both sides drop out. So we end up with negative 8 cubed equals negative 6h squared plus 12h minus 8. So everything on the right, because we've got a negative 6h squared, I'm going to put on the left hand side to form my quadratic. So I get 6h squared minus 12h plus 8 minus 8 cubed equals 0. So here's our constant term. I'm going to factorise that. So it becomes 8 brackets 1 minus 8 squared is equal to 0, and then I'm just going to divide everything through by 2, so I get 3h squared minus 6h plus 4 lots of 1 minus 8 squared equals 0. So using my quadratic formula, I know that h is equal to negative b, which is 6. It could be plus or minus, but actually it's going to be a positive value, being in length. Square root of b squared, 36 minus 4 times AC, which is 3 times 4 lots of 1 minus 8 squared, all over 2a, which is going to be 6. And if I plug that into my calculator, I'm not going to simplify that manually, I get 1 plus root 85, which is approximately 10.2 centimeters. Hope you enjoyed that.